All right, so here we go. I'm gonna walk you through this ACT question real quick, model how I would do this. The first thing you are gonna notice is that there's some writing and there's also a diagram. So rather than reading through all of that passage, we're going to pick out some of the key things that stand out to us. The ACT test does not give us enough time to read it word for word, so we need to have some strategies that we can use to just pick out the most important things. So the first thing I see are these italicized words, P waves and S waves. So I'm going to assume those are kind of important. And then also over here, I see the word refracted and bent. Here's another one, seismograph, and it gives us a definition. And also down here, I see focus. The word focus is italicized. Feel free when you are doing ACTs to write on the passages. Do anything that will help you. Highlight, underline, circle. I'm going to quick skip down here to the diagram. And rather than looking at every single part of this diagram, the first thing I'm going to do is look at the key. So I need to understand that I have P waves I'm looking at and S waves I'm looking at. Okay, over here, the earthquake focus they're pointing out. And then there's these also shadow zones over here. Okay, that also sticks out to me. So I may have to come back to that in a second to answer some questions. From there, we're going to go on the back and look at, there's a couple other diagrams and figures on the back here. So figure 2, okay, is showing you time earthquake starts at the focus. First P waves arise, first S waves, and then this is important because it's telling you for every one of those lines, 1 minute has passed. And then figure 3, again, we're comparing P waves to S waves. The first thing you want to look at are the labels on the x-axis and the labels on the y-axis, so you know what are those things that they're going to want you to use this chart for. Okay, let's start with number 1. Sorry, this is so fuzzy at times. Number 1 says figure 1 shows a seismograph located at a point 125 degrees around Earth from an earthquake's focus would receive which type of seismic waves, if either, from the earthquake. So the key thing here is they're saying we're going to 125 degrees. Okay, and it's saying which type of seismic waves would it receive. So if I go back to this first diagram, 125 degrees would be about here or about here. And if you were to look right here and read the shadow zone, it tells us that neither P waves nor S waves received at that seismograph. So my answer to that question then, I'm going to find the answer that says neither one. And that would be D. Okay, up to number 2. Again, it says according to figure 1, so we're going to go back to the beginning. When P waves encounter the boundary between the mantle and the core, what happens? The P waves most likely. So we're looking at P waves, and we want to know between the mantle and the core. So let's go back and look. First of all, P waves are represented with a solid line. We're looking at between the mantle, right here, and the core. Okay, so what is happening to these waves when they enter that? And you can see that they don't go straight anymore. Okay, they bend. And what was that term up here that means bend? Refracted. So let's see if that's an option. On number 2, and G says they enter the core and are refracted. So I'm going to pick G. Number 3, based on figure 3, so we're going right next door. For a given seismograph, the time elapsed between the arrival of the first P waves and the arrival of the first S waves from the earthquake focus, 10,500 kilometers away, would most likely be. So we're looking at distance here. Here's distance along the x-axis. It only goes up to 10,000, so we're going to have to estimate okay, what it would be at that point. So I'm going to go up here. I'm going to say it's probably going to continue like this, right? So now if I can estimate, I'm going to go over here. I'm going to say it's probably 13.5 there. And it's probably up here, if I were to continue it on, maybe 23. Okay, so let's see which one we're going to take the difference, right? So, because they want the time elapsed. So I'm going to say, let's see, if this is 23, it's probably going to be more than 23. It's probably going to be 24. So I'm going to say D is probably going to be the right answer. Okay. 4, based on the information provided, the time earthquake starts at the focus in figure 2, okay, so right here, corresponds to which of the following points on figure 3? Okay, so the time the earthquake starts corresponds to which of the points down here? Okay, and I would say that if it hasn't started yet, it's probably going to be right there. So that's F. Last question. According to figure 2, which of the following statements best describes the relative amplitudes? Amplitudes. Okay, amplitudes means how high, okay, or how much strength of the first P waves to arrive at the seismograph and the first S waves. Okay, so we're comparing the first P waves and the first S waves to arrive. Here's the P waves. Here's the S waves. What are some comparisons we can make? Well, right off the bat, it looks like the S waves are a little bit stronger, okay, and they last a little bit longer. So let's see. Down here. A says, let's see, the amplitude of the first P waves to arrive are smaller than the amplitude of the first S waves. Yeah, that could be. So we're going to put that. Larger than the amplitude of the first S wave? Nope. Non-zero? Nope. Or they're 0, as is the amplitude of the first S waves. No, they're not 0 because they're going up. So my answer to that one was going to be A. Okay, so some strategies I used there. Crossing out questions you know cannot be the right answers. Circling keywords, going back and writing on the figures or the graphs. Okay, and don't read through all of the information that they give you. You can always go back as long as you know where to go back to.